Okay, guys, last notes on statistics. I'm going to keep these ones pretty short. Okay, so these are going to be our inferential statistics. We talked a little bit about what an inference is, but an inference is different than a conclusion. We're going to talk about inferring information from the numbers that we gather from scientific data. Okay, so just a brief review here. So we already there we go. Descriptive statistics. Those are your last notes. So my descriptive statistics, that was more just like organizing data and putting it into ways where we could infer things from it. So we did those things where we talked about finding the average, finding the standard deviation. Is it a positive skew? Is it a negative skew? And then looking at its range. So it's kind of like just organizing the numbers into something that we can actually analyze later. All right. So talking about our coffee experiment, I'm going to keep coming back to that with the antelope teachers drinking coffee. The descriptive statistics would really just be finding like the average amount of teachers that were very alert or little alert, and putting them into something where we could make inferences from that data. So inferential statistics is where we interpret data and draw conclusions. An example of making an inference. So if I was looking at time on my x-axis, and we're talking about maybe months, so August, September, October, November, and then we're looking at grades, and let's say the percentage is going up, all right? So as time goes by, grades go up. Or look at it this way. You can infer that the student might have studied more, okay, because their grades are going up over time. You can infer that the class got easier, right? So you're trying to draw conclusions from the graph or the data, the numbers. Why we do that? I want you to read through this and take some notes down. I'm going to summarize it really quick. But I want to tell you that we do this with a lot with testing out new drugs. Okay, so antidepressants, anti-anxiety, heartburn, anything like that, where we're trying out a new drug. We try it with a sample population, and then we want to be able to take those results in that small population and apply it to the entire population. Okay, so there's numbers out there that tell you whether or not it's enough population to be, big enough population to apply it to other populations. So they say like 1,500 people. If I find what's true of 1,500 people in a population, I can pretty much apply that to the entire population. So there's always a chance for error when we find these statistical, when we say something's statistically significant. And that's why, so let's go down here. So the hypothesis and results must be tested for significance. And that's what we're going to do with our inferential statistics, okay? So again, up here, we're allowing us to say if it worked for this population, it's going to work for all, and that's based on something called the probability theory. We talked a little about that with the jar. Remember, if you pour out the marbles, you can do a good sample size that way. So what is statistical significance? That is when I'm making sure that the difference is not due to chance. Okay, it needs to be pretty high up to be statistically significant. We say that it needs to be about 95% or greater, that the likelihood is due to whatever it was I was changing, my independent variable, that it was due to the antidepressant, that it was due to the anti-anxiety pill, and not due to chance. Okay, we represent that with something called a p-value, and the p-value is actually representing the chance of or the statistic of chance. So I want my p-value to be less than 5%, 0.05, because that means that 95% greater chance is because of what I was changing. Okay, so remember we talked about the coffee again, so I'm making sure that it's the coffee and not anything like the placebo effect or other factors going into the chance that that maybe the teachers are more alert. Okay, now we're going to talk about something called a hypothesis and a null hypothesis quickly. Refresher. Hypothesis, my if then this happens. If I drink more coffee, then I will be more alert. Okay, remember, it must be testable, must be refutable. We're now going to add in something called a null hypothesis. And we'll practice this, but the null hypothesis is basically the opposite of the hypothesis. All right, so here is my hypothesis example here. Gender has an effect on perceived intelligence. Then my null hypothesis would be gender does not have an effect on perceived intelligence. So for our experiment, my hypothesis would have been coffee has an effect on alertness. My null hypothesis would be that coffee does not have an effect on alertness. That sounds really silly to have a null hypothesis, but we're going to look at some types of errors that occur and why it's important to know that. My purpose is to basically, this is kind of like a you are innocent until proven guilty type of thing with research. And basically that means when I'm doing a scientific study and researching, I have to, until my research shows that there's until I prove my original hypothesis, I have to assume that the null hypothesis is true. Okay, so until the research shows that there is a difference, the researcher must assume that any difference is due to chance. Okay, so I'm assuming my null hypothesis is true until I can prove otherwise. And I have to prove that, remember, by that p-value of 0.05 or less, or that's saying that 95% or higher is not due to chance. Okay, there's two types of errors that can occur with this. There's type 1 error and type 2 error. This graph seriously made no sense to me until I used the application. So what I'd like you guys to do is like pause it and copy this down, and then we're going to talk about the example. Okay, so pause it right here, copy down what is the null hypothesis, and then the researcher's decision, this graph, and then type 1 and type 2 errors. Okay, but let's look at the example, and then you guys can go back and apply it. So my type 1 error is when I reject the null, and the null is actually true. So error is bad, right? I made a mistake. My type 1 error is I rejected the null, and then it's actually true. Okay, versus the type 2 error where I accept the null, and yet the original hypothesis is actually correct. Okay, so they're both wrong, but it makes a big difference in an actual situation. So let's read this situation because let's make this make sense. So there's a bomb threat called into the front office, and we need to evacuate the school. That's the hypothesis, okay? That there's a bomb threat called in, and we need to evacuate the school. So the null hypothesis is there is not a bomb at the school, so we do not need to evacuate. So see how that's the opposite? Now let's apply that to our chart. So let's talk about our errors, okay? So if the null hypothesis is true, if there is not a bomb at school, so we do not need to evacuate. If I'm the researcher and I reject that null, then I would say that there's not a bomb, and we reject the idea, but we evacuated the school anyway. So the null was wrong, the null hypothesis is true, and I rejected it, and we evacuated the school anyway. That's a type 1 error because there wasn't a bomb, okay? Versus the other way around. There's not a bomb, and we did not evacuate the school. This would be a correct decision, okay? So the null hypothesis is true, and I failed to reject the null hypothesis, so we did not evacuate the school. All right, so this is a correct decision. Opposite, the null hypothesis is false, so that there's not a bomb in the school, so we do not need to evacuate. That's wrong, and we did evacuate the school anyway, so we rejected the null. That would be a correct decision because there is a bomb, and we evacuated the school. Correct decision. Now let's go this one. The null hypothesis is false. There is a bomb, and we did not evacuate the school. Type 2 error. Okay, so they're both wrong, type 1 and type 2, but we're just looking at whether the null was accepted, whether the null was true or false, and whether or not we rejected or failed to reject that. Bring this to class tomorrow. We're going to look at other examples, and hopefully this will make a little bit more sense when we apply it a little bit more.